Events. In the lesson on event loop, we saw how drawing and events were the two most important operations in the UI. In this lesson, we'll focus a little more on events. First, let's look at the flow of events within a system. Now, we all know that the input events originate from the hardware, like the clicks from the mouse, taps on the screen, keyboard events, and even microphone and webcam events. These are all events that originate at the hardware and flow up the stack through the operating system into the Windows server and finally arriving at the application. The thing to note over here is that as the event propagates up the stack, it accumulates context from the layer it goes through, and each layer adds more to that particular event. Finally, when the event arrives at the application, it has all the context it needs to actually process it. The Windows Server, in particular, plays a very important role in contextualizing the event for the application. We all know that the Windows Server, or the window manager, as it's called on some systems, manages a set of windows across the entire desktop. When an event arrives, it first looks at the foreground window and then directs the event to that particular window by applying a bunch of coordinate transformations, adding some timestamps, and a bunch of other details, and then sending it to the application. Now, once the event reaches the application, the propagation is what happens inside an application. Now, event propagation really depends on the way the UI is structured, and we know that we can do it in a retain mode fashion or with an immediate mode. And that also dictates the way the events propagate within the UI. Let's first look at the case of the retain mode. Now we know that in a retain mode, the UI actually is composed of a hierarchy of layers, which also maps to a tree of components in the object model. Now let's take the case where the user has tapped on the blue box. When the event arrives over there, the blue component can get a chance to handle it. If the component doesn't handle it, it can go up the ancestor chain to its parent. Now the parent can choose to handle it or ignore. If it ignores, it can continue up the ancestor chain all the way up to the root, where it can get handled or completely ignored. Now this process of the event moving up the ancestor chain is called event bubbling, just like bubbles that float up into the air. What goes up can also come down. In contrast, when the event arrives at the blue component, instead of getting handled over there, it goes straight up to the root. Now the root can decide to handle it or ignore. If it ignores, it goes down the descendant chain until the blue component. Now each child in this descendant chain can get a chance to handle the event, or ignore and pass it down. Now when a parent handles the event in the descendant chain, it seems like it is capturing the event. And that's why this type of event propagation is called event capturing, which goes top down, and every child in the descendant chain can get a chance to capture and swallow the event. So event bubbling and capturing are the two ways in which events can propagate up or down the hierarchy in a retain mode UI. Now in case of the immediate mode, event propagation is far simpler. Since there is no UI tree to deal with and just a flat bitmap, the event propagation is just a matter of doing some hit testing on the bitmap itself. Normally, you would look at the hit point and compare it against the bounds of various elements you've drawn on the screen. Of course, it's your responsibility to keep track of all the elements and their bounds and use that for the hit testing. So, in other words, the immediate mode is a flexible, roll your own strategy for event handling. Now, what exactly is event handling? Well, it's the process of executing associated callback with any particular event. Too abstract? Well, let's dig a little more deeper into this. Now, in a UI, you normally associate a function that needs to be executed when the event arrives. And this is done before the event actually occurs. And that's one of the reasons why UI is treated as an event oriented programming model. When the event does happen, the event loop inside your application will put a message inside the message queue. And there could be other messages as well, which the event loop should be processing. At some point, when the event loop is ready to process our message, it'll pull it out of the message queue and look up the callback function that needs to be executed for that event. Now, this function goes on to a call stack, executes, and at some point completes. At that point, we say that the message has been processed and the event has been handled. So that's in a nutshell the life cycle of an event. It starts from the hardware and propagates up the stack, accumulating context and arriving at the application. Inside the application, the propagation happens depending on the rendering type, whether it's retained or immediate. Handling the event is all about executing the associated callback function. Now we do know from the event loop lesson that this function should execute within 16 milliseconds. Oh, by the way, events are how you give the control back to the user in the user interface.